Hi, friends. Once again, welcome to Passiontronics, my YouTube channel. Friends, today we will study branching instructions of microprocessor 8085. Let us move to that. Friends, these branch instructions actually changes normal sequence of program execution. We have studied how microprocessor execute the program, and it is the program counter that helps microprocessor to execute the given program. Actually, program counter holds the address of next instruction to be executed. For example, on this slide we have a sample program. We are not exactly interested in the what instructions are there, but suppose that that program begins at C100. The first instruction is at C100, and then there are subsequent instructions like this. Usually this execution goes in sequence, one after the other, like this. For example, the first this instruction will be executed, then my program counter will point to C101, next instruction will be executed, and so on until the last instruction. So usually this flow of execution is a sequential, and we call this as a normal execution of program. Okay, but now at this point of time, you see we have introduced JMP C570. So this is the branching instruction, and this is actually unconditional branching, unconditional jump. That means it is a compulsory. So jump means actually here you are forcing microprocessor to transfer the control of execution to the addressed instruction. And what is the address given here? It is C570 hex. It means that from this point, the next instruction executed will be at C570. And that's why the jump instruction, what it does actually, C570H gets loaded into the program counter. And therefore, that will be the next instruction to be executed. And therefore, for this case, how it will execute? Say, it will execute like this. It will execute this instruction, this instruction, this instruction. It's okay up to this, but at this point the instruction is JMP C570, and therefore the execution or the control will transfer to the instruction which is at C570, and this is an unconditional jump. That means for this case this part will never be executed because this is unconditional jump, compulsory jump. This jump is example of again forward jump. So that means you are at the some top level C103, and thereafter you are jumping to the lower instruction. You can call this as a forward jump also, right? So let us go to the next slide. Uh, Here, the other case, that is a one more example of unconditional jumps. For example, the instruction is JMP C103H. So I have taken this deliberately so to illustrate the example, that is backward jump, right? Now you see this is a normal program, ordinary instructions, and it will come over there straight away, no problem, because there is no jump instruction here. But at the address C571H, the instruction in program is jump to C103. Therefore, program counter will get loaded with C103X, and therefore the next instruction to be executed will be this one. Why this one? Because it has the address of C103, and you can see that it is coming back. So these jumps can be forward direction, this can be reverse direction, or in other words, the control can be transferred to any instruction in the program or even instruction in the subprogram also. So this is the case of unconditional jump. No condition is required, it is a compulsory, right? So let us move to the next slide. Yeah, this slide just illustrate displays all the branching instructions of 8085. So we have three important branching instruction. This one, that is jump, then we have the call instruction, we have return instruction, and today actually we are focusing on jump only. And again in jump we have unconditional jump that we have studied just now, and we have conditional jump also. Now, what is the meaning of conditional jump? Conditional means what actually jump does when the jump is executed, control is transferred to the addressed instruction. That's all right. But now you can have several conditions. So actually we have eight conditional jumps with 8085. And what are they? Just I have listed here. This is JZ, JNZ, JC, JNC. What are these? Actually, these are the conditional means here. There are four flags we have studied, total five flags, but out of that we have zero flag, carry flag, then we have sign flag for sign arithmetic, and also we have parity flag, right? So you can have, you can you can say have embed some condition in that jump instruction. For example, here it is JZ, JZ, J for jump, Z for zero. That means the control will be transferred. Jump will occur only if that specified condition is met. Otherwise, it continues the main program. So for zero flag, we have jump if zero. That means if result has occurred, result zero has occurred. J and Z. That means if result is non-zero, then it will jump. I repeat, jump will be followed, control will be transferred only if the given condition is met. Else, it continues the next sequential instructions. That means there is no branching. Here, the next is JC. That means if carry has occurred in the last instruction, then only jump will be followed. If no carry, then it will not be jump. You can have jump if not carry. JNC means jump if not carry. So jump will be followed only if the carry bit is zero, no carry has occurred. Then next we have jump with positive. You know that the most significant bit of the accumulator of the data is reserved for the sign. And if that sign is zero, means that number is positive. And when you see that jump is positive, that means if the result is positive, then jump will be followed. JM means jump if minus. That means if sign bit is a 1, that means that indicate that given data, given number is the negative number, and then only the branch will be followed, jump will be followed. Then we have the last, that is JPE and JPO. There are two instruction, jump if parity even and jump if parity odd. What is the parity actually? We have the 8-bit data, and if the number of ones, how many are they can be 2, 4, 6. That means they are even, then its parity is even. And if they are odd means 1, 3, 5, like that, then its parity is odd. So that condition also can be used for the branching. So these conditional jumps are required in the developing the program for a given task, and that are very essential, right? So Let us consider one example here, full example, that is a jump if not zero. This is the syntax. Syntax means how to write this instruction, right? So you can write this instruction J and Z ADDR. Either you can mention address here or you can have the name of the instruction. So branching will occur only if the condition is met. Just we have discussed that, and this is the case. We have taken one example J and Z, jump if not 0. Where to jump? Address is given C103, and therefore this instruction will load program counter C103H only if result is non-zero. So look at this program. I have shown program in the RAM. These are the addresses of the instruction, and these are several instructions, right? See that so far up to this there is no problem. It will execute in this order from 00 to say C102, no problem. But at this particular location, the instruction is jump if not 0. अगर रिजल्ट नॉन जीरो है तो जंप होना है, और रिजल्ट जीरो है, अगर एक्यूमुलेटर में जीरो आता है तो यहाँ जाना है. तो जंप कब होगा? जंप इफ नॉट जीरो. कहाँ जंप करना है? एट C570. दैट मीन्स अगर एक्यूमुलेटर में नॉन जीरो रिजल्ट आता है, from this control will be transferred to this instruction. Why this instruction? Because address is C570 which is mentioned in that J and Z. और अगर रिजल्ट जीरो आता है तो ये जंप, अगर जीरो नहीं है तो इधर जंप होना है, लेकिन जीरो है तो continue. See here, jump to address instruction only if result is not zero. That is when zero flag is zero. Else continue with the next instruction. अगर result zero है तो it will execute this part. अगर zero नहीं है तो execute. See that this is the branching. Depending upon what is the result, and result is for testing the data. Therefore, what is that data? Depending upon that, you have to choose the path in the program, and that's why these conditional jumps are very important. Or you can say that no program is complete without jump and conditional jump instructions. So, this is time to stop here. See you next time with new instructions. Bye.